to the standard of complex mass, you are supposed to evaluate this complex integral and along a contour which is given by z exponential e and the z is equal to 4. So there are two poles. The pole it is a point where the function is not defined. The first pole is at z is equal to 2 and this pole is inside this past case. Then z is equal to 3, it is outside for the first case here. So for the first case, z is equal to 3, it is outside. Using Cauchy integral, the answer is given by I power I2 pi sum of the residue along the contour. Sum of the residue along the contour. Now, in this case, sum of the residue along the contour is given by, for the pole at 2, it will be given by limit as z tends to 2, then z minus 2 multiplied by exponential power z divided by z minus 2 multiplied by z minus 3. So z minus 2 will cancel out and we are going to be left with the limit as z tends to 2 exponential z divided by z minus 3. Then we substitute z with the 2. When you substitute z with the 2, exponential 2 divided by 2 minus 3, you are going to get 7, negative 7 minus 4. That is the result. Then by Cauchy integral, integral along contour C of exponential z dz divided by bracket z minus 2 multiplied by z minus 3 will be given by I 2 pi multiplied by negative 7 minus 4.4, which is equal to negative I 14.8 pi for z is equal to 2. For this other case, for z is equal to 3, it is inside this contour where z is equal to 4. So z is inside. As a result, now using Cauchy integral theorem, the integral is given by I 2 pi r at the pole, which is given by r is equal to z is equal to 3. So the sum of the poles at r at z is equal to 3 is given by limit as z tends to 3 of z minus 3 multiplied by exponential z divided by z minus 3. Then you have z minus 2 that, which is equal to exponential z divided by z minus 2, because z minus 3 will cancel. Then when you evaluate, you are going to obtain, you substitute z with the 2. You substitute z with the 2 here. Yeah, you substitute z with the 3, this 3 here for the limit to obtain this result here. Exponential 3 divided by 1 is 20.1 equal to 1 decimal place, meaning that the integral of this function along this contour is equal to 2 pi I sum of the residue at pole 3, which is given by 40.2 I pi. So our solution are as follows. The integral of this complex number is equal to negative I 14.8 pi for this contour at the pole z is equal to 2, and for this other case it is I 40.2 pi for the contour z is equal to 4 where the pole is equal to 3. So thanks so much for taking your time to study with me on how to evaluate the integral of a complex number by applying the Gauss integral formula and following this simple method steps to obtain our working. Remember, for more such learning, you can always tune on to my YouTube channel so that we may learn together. In case of any query, you can comment in the comment below. Also, if you have any other approach which you think it can be applied, kindly consider to do so and to consult me so that you may keep learning together such areas of mathematics which are so important for us. Bye bye, see you in the next presentation as you keep on learning.